All right, welcome back. So we're going to start with an example. Our example is actually number 80 in the textbook. Okay, and it gives us this information. A sub n is 1 over 2,187. Okay, and our sequence is given by 3, -1, 1/3, keeps on going. Now, one good thing to sort of check is, well, what would be the next term? The next term would, of course, be -1/9. After that, 1/27. So we sort of know what the sequence is going to be. Now, let's take a look and actually get our a sub n. So our a sub n, remember, should equal a sub 1 r to the n minus 1. Okay? It's good sometimes to have these formulas, particularly in a case like this, where it could get confusing if you try to drift away from it. Okay? So, our a sub n, our a sub 1 is 3, and our r here is what's going on here. Every time we're dividing by -3, or thinking multiplying by -1/3. Okay, now here I'm going to be a little bit very careful with my math. Okay, so definitely -1 to the n minus 1. Okay, but now what do I have? I have 3 divided by 3 to the n minus 1. Okay, so I want you to sort of realize what's going on here. This -1 over 3 to the n minus 1, I've sort of split. The -1 on top sort of came out in front, and the 3 sort of staying over here. Okay, why? Because I'm going to end up writing this as a sub n equals -1 to the n minus 1 over 3 to the n minus 2. Okay, now we have to solve this. Okay, so 2,187, that equals 3 to some power. Okay, let's see if we could solve that. Well, we could always know that 2,187 is a specific power of 3, but I'm not good at that. Okay, so I'll go back to logarithms. Remember that? Log 2,187 equals log, oh, use the same log, 3 to the x. So x is natural log of 2,187 divided by natural log of 3. Gives me 7. Okay, so n minus 2 equals 7. That means n is going to have to equal 9. Okay, now, let me write that down. Okay, now I'm just going to double check and make sure that works, because I wouldn't have to normally, but that minus sign, I just want to make sure that it works. So, a check, a sub 9 equals -1 to the 8, which is going to be positive, over 3 to the 7. 3 to the 7 is 2,187. And -1 to the 8th is going to be +1. Okay, so this one is, in fact, correct. Okay, all right. Geometric series. Now remember, a sequence and a series is a little bit different. The series is when you're actually adding the terms together, right? So take a look at 1 plus x squared all the way up to x to the n for now. Okay, so this series, I can actually, let me write it out. First, it can be written in a summation notation. N goes from 0, oh, not n, sorry. Let's write j goes from 0 to n of x to the j. Okay, so that's one thing to write. But another thing you can notice, and I'm not expecting you to have noticed it, I'm expecting you to understand it when I explain it to you now, is that it's 1 minus x to the n plus 1 divided by 1 minus x. Okay, now there's two ways to think about it. The way that I'd like to think about it more is I'm going to just do the multiplication. 1 plus x squared all the way up to x to the n times 1 minus x. So if I do that, first terms, when I multiply everything by 1, it's just going to give me that sum. Second, when I subtract, I'm going to multiply all of these by an x. So x times 1 is x, minus x times x is x squared, minus x cubed. Oh, actually, those are all pluses because of this minus x to the n minus, and x to the n plus 1. Okay? Just put that in there better. So what's going on here again? So I'm taking 1 times all of these. That's this first row. Okay? Minus x times all of these. That's this row. Okay? These all cancel. There's an x cubed there that's not written. That's canceling, and we're left with 1 minus x to the n plus 1. Okay? So what's going on here again? Let me move it around so that it's a little bit clearer. Okay, what's going on here? Let me try to do this a little better. This sum is equal to this expression. Okay, and the way that we get there is by multiplying out the sum times this divisor. There's another way to do it actually that I thought about, and that's involving doing the division. So if we do x to the n plus 1 minus 1 divided by x minus 1, that's also going to be the same thing, right? Because the minus, they both change signs. Okay, so let's do that. So x to the n plus 1 divided by x is going to be x to the n. Okay, multiplying through x to the n plus 1 minus x to the n. Subtracting. Okay, these cancel. You're going to be left with x to the n minus 1. Okay, and then you would just keep on doing this. You just keep on playing this game. Multiplying this by this, you're going to get x to the n minus x to the n minus 1. Subtract. Okay, you're just going to keep on playing this game until you get to 1 at the end. Okay, so that's another way of seeing that same relationship. Okay, so let me write that down one more time. The sum, let's write it k, I like k better today, goes from 0 to n of x to the k, which equals 1 plus x squared all the way up to x to the n equals 1 minus x to the n plus 1 over 1 minus x. That's the traditional way of writing it. But we could also write it as x to the n plus 1 minus 1 over x minus 1. Okay? So that's all that work was for that. Okay? We'll do a couple examples with that in the next video.